All right, let's go ahead and let's get started. I hope everyone's okay. I know that it's going to be kind of a weird situation with what we have to deal with. I know that we'll get through this and we'll be okay. What I'd like to try to do is try to help you out with how we'll be working through our class here as we try to continue on with class. And so, what we'll do first is I'll go over with you how we'll get things done online, um, procedures that you'll have to follow, and then that ways, if you have any questions at the end of this discussion here, you can just go ahead and either you can email me, and I'll respond to your emails, or you can just add comments on our Google Classroom page, and I'll respond to that. So make sure you check your Google Classroom. I'll be communicating with you guys quite a bit through Google Classroom. I'll be posting materials on Google Classroom. These Edpuzzle videos will be also posted on Classroom. You'll submit all of your assignments through Google Classroom, and essentially I'll be able to keep track of your work through Google Classroom. So we'll make use of it. Okay. So what I have in front of you right now is the schedule. I think all of you received this as an email, but I just want to quickly go over it with you. So the periods, we don't have rotating periods. It's going to be straight periods 1 through 6. For our class, we'll start our meeting at 11 o'clock. So please make sure by 11 o'clock, right after you log out of your third period class, make sure you log into our class at 11 o'clock. I'll start it right away. What we'll do then is you'll watch the Edpuzzle video. The lecture I will post as an Edpuzzle video, and you'll watch it. You'll answer the questions. You will have the 50-minute time period for our class to get the work done. That means you'll answer the questions in the Edpuzzle videos, as well as the questions that I'll ask you to do towards the end of the video. But you should be able to get all that work done within the 50-minute time period that you see right there. Okay, so please make sure you get that done. I'll go over with you how you'll submit it. And during that time, if you have any questions, you can add comments to Google Classroom. I'll be here to check your questions and answer your questions as well. I'll try to leave a little bit of time towards the end of our period to take your questions, but as you'll see in just a moment, I will have my regularly scheduled office hours after school. And so we will do that as a live Zoom session, and I'll talk to you about how you'll get onto Zoom and get that done as well. Okay, so again, please make sure that you are online and you're ready to go at 11 o'clock. That way, then you can finish the portion of the video before you start on the problems and get everything done and submitted by 11:50. I will try to keep the videos, and I will make the videos. I'll keep them to about 20, 25 minutes, so that ways you can have time to do the work that I ask of you and then submit it as well. Okay, so please make sure you get that done. Okay, so first thing, what you're gonna have to do then is you'll have to log on to Google Classroom. Make sure you do that. We've done this before, so I don't think it should be too much for us. You'll log on. I'll have the Edpuzzle video posted for that day. The videos will be of our lectures, and so it'll be the lecture notes that I've posted for you in Classroom. You'll have access to that as well. And so make sure you get the work done. Like I said, I will try to keep the Edpuzzle videos to about 20, 25 minutes to give you some time to get your work done. So what you're gonna have to do then is that you'll watch the Edpuzzle videos like we've always have done in the past. You'll answer the questions on the Edpuzzle videos, and you'll input your answers there as well. However, what I'm going to ask you to do then is that for certain problems, and these problems will be our problem set problems, the problem sets we do in class. For those problems, I'm going to ask you to work those out on a separate sheet of paper. You will do your work there, and then what you'll do then is you'll submit your answers on Edpuzzle, and then you'll start the Edpuzzle video, and I will do the solution for you, and then you will write down that solution on the same sheet of paper that you just did your work. So you'll do your work, you'll do the work that I've done for you, so you'll have it there. So make sure you copy down that solution to the problem set problem, And then what you'll do with that is once we're done with the video and you have completed all the problems that we have asked you to do, then what you'll do is the video will stop. At the end of the video, there will be practice problems that will be taken either from the book, or I will assign 1, 2 practice problems for you to do. You'll work out those practice problems on the paper as well. And then when you're done with that, you will go ahead and submit that through Google Classroom as classwork. And I will have a Classroom link for you so that you can submit it like we normally do anyway. Okay, so make sure then all your work is submitted on time. Like I said, you have till 11:50 to get that work done and submitted on time. So the work that you'll be submitting at 11:50 will be the problems that we've done in class, the problems that you had to work on the videos, and also these extra practice problems at the end. So I think once we go through the videos and you get it done, the first video will kind of make it clear on what you have to do, and I think afterwards things will run fairly smoothly. Okay, I know that it's going to be the transition is going to be a little bit more difficult at first, but I think what we can do then is if you have any questions, again, like I said, make sure you email me or comment in the Google Classroom. I'll take a look at it and I'll respond. But I think this will work out. So this is something new for all of us. I think I'll need as much help from you as I'll try to help you with this. Okay. Okay. So let's get started here. Okay. Real quick. So on your separate sheet of paper, what I'd like you to do then is just real quick, write down what time does first period start during the day. Okay. So go ahead and answer that on your paper, and then I'll start the video, and then I'll work out the problem for you. Okay, so if you notice here, this is what I've done. On a separate sheet of paper, I've written down my name, period, the class that our period, our class, the day on the upper right-hand corner. If you notice, and I've also listed for you, I've written down the day. It'd be helpful for me if you included all this information. So the date here, the day, again, your name, period, class, and then the problem that you're doing and your answer right there. So this is your answer to the problem. And then what I'll do then is I will pause and we'll continue. You'll write down this answer onto Edpuzzle. You will include that answer into Edpuzzle, and then you'll start the video, and then I work out the problem for you. So what happens is then I will have this and I will answer the question for you. I'll work it out, and I'll say then that class first period starts at 8 a.m. And then what you would do then is on your paper, there's the answer, and I'd work it out for you. On your paper then, you'd write down the in-class solution. That's the solution that we came up with in class, and you'd write that down underneath your solution. So same piece of paper, your answer to the first problem, and this is the problem, this is the solution that I gave you here in class. So what you'll do then is you'll, on this same sheet of paper, you'll continue on, you'll do the next problem. Underneath that, you'll write down class problem number 2, for example. Okay. You'll write down your answer, and then you'll input that answer onto Classroom, and then you'll check how I did the problem, and then at the end of the period, at the end of our period, you'll take this as well. You'll submit this work as well as the one problem, like I said, 1 or 2 problems that I'll choose from either your book or my own problems to have you do to kind of reinforce what we've learned here. Okay, so that's what you'll turn into me at the end of the period, and make sure you have this submitted. You can take a picture of it just like you've done all of your other assignments. The homework, for example, you'll take a picture of it. You can scan it on your computer, or I'm sorry, on your printer, and then submit that online. Okay, so I think this would work out pretty well for us. It will give me an opportunity to see how well you understand the material. And essentially, this is what you would do in class anyway, except for you would do it on your problem set, and I wouldn't collect it until the end of the before your exam. Okay. So I think this will work. I hope then that from this type of interaction, so you'll be including that from this interaction, or you'll be able to learn the material, and like I said, I can get some feedback from you. Okay? So what you'll do then is, like I said, you'll complete the rest of the problems that we do together on the video. You'll turn that in, and then at the very end, what you'll do then is there are 1 or 2 practice problems. Again, these are problems that I'll either draw from the book, or I will take, I'll have for you that you can practice, that you'll do on your own, and then you'll submit it to me. And make sure, again, I don't want to emphasize, I want to make sure I emphasize this for you, that you have to turn it in before the end of the period, which for us then would be 11:50. So again, our class is from 11 to 11:50. So please make sure that you have all this work done and submitted by 11:50. Again, I told you I try to make sure that the lesson here will not go beyond 25 minutes. That way you have time to get your work done. Okay. All right. Let's go ahead then and continue on. I will be available every day, like I usually am, from 3:15 to 4:15. We'll go past 4:15 if we have to. If enough of you come online and ask your questions, I will take all of your questions, and we'll finish up when we finish up the last question. Okay, so roughly about 3:15 to 4:15 though. These sessions will be live. I'll be using Zoom. I'll talk about that in just a moment. So that way, then you can ask your questions. There'll be and you'll get the immediate feedback. But do understand, during the video, you can, or during our class time, you can communicate with me through email. You can communicate with me through Google, the comment section in the Google Classroom. I think that would be faster. I'll be checking those during our class period. I'll be answering your questions through them as well. And so what I would like to do with this, the office hours here, is that you'll get a chance to interact with me through Zoom. And again, it'll be a live interaction. Make sure you ask your questions that you had during the video. Maybe if you have questions about your homework, make sure you ask about that as well. Okay, so that's available to you, and I will be available to answer all of your questions at that time. All right, so to get onto Zoom then, you'll just type in the link right there to your the address window. You'll type that in, and then you'll log in between 3:15 and 4:15. We'll be using that same link every day, and you can and that way we'll interact with each other through that. You don't have to memorize anything, so you'll just use that same link to get onto Zoom, and from there we'll go ahead and proceed with your questions. Okay. Okay. Well, like I said, I think this will work. I will see how well it works. We'll see what adjustments we have to make with it, and then we'll take it from there. Okay. I think we will have to be fairly patient with this process. I think it's kind of new for all of us. None of this we've anticipated, so I think it should be okay. I will continue also to make announcements at the beginning of class. I'll let you know what's going on, just like what I do during the regular day when we meet at school. I'll make announcements at that point. In regard to quizzes and exams, I think right now I'm going to hold off on that. But again, that's somewhat fluid. I'll let you know if there is a quiz. There will not be any exams, but if there are any quizzes, the format, I'll let you know, and we'll take it from there. Okay. But as of right now, let's keep this where we have it, and I think let's try to work out all the issues here first, and then make it work. Okay. All right. Well, let's go ahead then. I hope, like I said, I hope this helps a little bit. Like I said, make sure you ask questions if you have any. Always ask a lot of questions, and I encourage that in class, and I encourage it much more so now. Okay. Let's go ahead then. We left off last Friday. On Friday, we left off with this discussion of polarity, electronegativity, and how a bond can be determined then as either being polar or non-polar. Remember, electronegativity increases as you go up and towards the left in the periodic table. We talked about how then that the electron affinity of an atom is basically defined then as the ability of the atom, or the way that the atom, how strongly the atom pulls electrons towards itself. And so you want to keep that in mind. So when two atoms, remember, get together, they will try to achieve a lower energy state. They're going to try to make sure then that when they are together, that that interaction that they have with each other lowers the energy state for both of those atoms. And so we talked about that already. Now, when two non-metal atoms get together, then we have this sharing of the electrons. The electrons can sometimes be shared equally because the two atoms are equal in electronegativity, or they can be shared unequally when two atoms have a difference in their electron affinity, that one is stronger than another. Then the electronegativity difference will be greater, and the greater the electronegativity difference between the two atoms, the more polar the bond will be. And that's what this table points out to us. Okay, so you can imagine then we're dealing with the difference in electronegativity as indicated by this Greek letter delta. Okay, this is the difference in electronegativity values. And we saw then with the Pauling equation, we can actually solve for this this value right here. So the electronegativity. I hope that you folks are able to work on it and practice that a little bit. Okay, so difference in electronegativity, the greater that difference, if the difference is greater, the more polar the bond will be. So if the difference there is 0, so for example, if you had two hydrogen atoms bonded together by a single covalent bond, these two, the difference, obviously, since it's the same atom, the difference between these two then would be 0. And in that instance, then the bond then is going to be a non-polar covalent bond. Okay. The electrons are shared equally between those two atoms there. Essentially, then the electrons don't favor one side or the other. So therefore, neither side then has a charge associated with it. Okay. And so again, we're talking about this bond right here. Okay, the bond is going to be polar or non-polar. Now, if the electronegativity difference is greater than 0, so I would say then if it's between 0 and 0.3, and again, the range here is somewhat arbitrary, but not quite. We say then that this is still going to be a non-polar bond. So even though the electronegativity difference is greater than 0, if the range is between 0 and 0.3, we continue to call that a non-polar bond. Okay, so non-polar covalent bond between 0 and 0.3. Now, the electronegativity difference, if it ends up being greater than 0.3, okay, but say less than 2, so if that difference is greater than 0.3, but less than 2, then what we have here then is a polar covalent bond. And in that case then, for example, if we have hydrogen chloride, hydrochloric acid, hydrogen chloride here, hydrogen chloride, then the difference in electronegativity here, chlorine is much more electronegative than hydrogen. And so therefore what happens is that these electrons then will favor that side of the bond, okay? Setting up then a charge difference here where this side then is going to be somewhat negative and this side is going to be somewhat positive. And we use little Greek letter delta because this is not a full negative charge on this side, nor is this a full positive charge on this side, because the electrons are still being shared. This is still a covalent bond. The electrons are being shared. It's just what happens is that these electrons then will spend more time on this side of the bond because they are more attracted to chlorine. Chlorine is more electronegative. Okay? So that's why then this bond is called a polar covalent bond, and we can use those electronegativity values if we are provided with them to find out then whether the bond here is polar or non-polar. Okay? Now, I'll talk about in just a moment how we can do that without the electronegativity numbers. We don't actually need those numbers as long as we remember the trend in electronegativity and also the location. If we can locate the atoms on the periodic table, we can make that determination we can make the determination about the polarity of these bonds without the actual numbers themselves. Okay. All right, finally then, if the electronegativity difference is much greater than 2, so if it's 2 or greater, okay, then we refer to that bond then as an ionic bond. Typically then it's going to be then a metal and a non-metal that will account for that. Okay. The electronegativity difference between those two then so great that the more electronegative atom, chlorine in this case, takes the electron completely, setting up then a full positive charge and a full negative charge, thus giving us a ionic bond. So we can consider then ionic bonds, if you want to think about it, extremely polar bonds. Like ionic bonds then, the extremely polar bonds. Okay. So that's how you can kind of imagine this as well. All right. Okay, so that's kind of a review of where we left off with yesterday. But like I said, we don't need the electronegativity values. And in this very first problem here, you're not given any. And so how would you determine then the strength of the bond here, or the polarity of the bond here, based on the strength, the electron affinity, electronegativity of these atoms? Well, you have to remember then that the electronegativity, remember, increases as you go up a group and across a period. So in that case, then the most electronegative atoms will be occupying the upper right-hand corner of the periodic table. So what can we do with that? Hey, hello. How are you? Are you testing us? Okay, no, that's right. Yet I'll see you guys tomorrow. Okay.
Yes.
Okay. Okay. Bye.
Bye.
Okay. And so the atoms in the upper right-hand corner here will be the most electronegative of these atoms. Okay, and so the further apart these atoms are on the periodic table, the more electronegative, the greater the electronegativity difference will be between the two atoms. Okay, so let's go ahead then. And what I'd like you to do is, for the three groups here, I want you to list these atoms for these bonds, the bonds between these atoms, from greatest to smallest. Okay? So again, what you want to look for then is how far apart these atoms are on the periodic table. So go ahead. I'm going to pause right here. This will be the first class problem that you'll have to do. So make sure you get that done on your piece of paper, and then I'll go over it with you. So go ahead, take about a minute or so to put these three groups of atoms in order of polarity from greatest to least. Okay? Go ahead and get that done. Okay, so let's go ahead and let's take a look at the first list here. Right, so look at the periodic table. Then each one of these groups here has fluorine as one of the atoms, and we know that fluorine is the most electronegative of the atoms. It's the most electronegative of all the atoms, and so what you want to look then is the position of these atoms here. The further they are from fluorine, the greater the difference will be. And that's a general pattern that will hold for the most part. Okay, so with that said then, if you take a look at this, carbon is furthest away from fluorine. The nitrogen, oxygen, carbon is the furthest away. So therefore we expect this bond here, the bond between carbon and fluorine, to be the most polar, okay, because they're furthest apart. Then we have nitrogen and fluorine. Okay, that bond will be next. Okay. And then finally, then, if you take a look at this, oxygen is the closest atom to fluorine, so oxygen-fluorine bond will be the least polar. And so this is the order of polarity for those bonds. Okay. So if you take a look at the next two, okay, so there's carbon, the first group right there. If you take a look at the next one, we expect then that the most electronegative atom, the problem here now is that you have fluorine for those two groupings, but this is oxygen here. The idea that what you're going to do is still basically the same. The further apart these atoms are from each other, the greater the electronegativity difference will be. So if you take a look at this, nitrogen and oxygen, even though this is not fluorine, nitrogen and oxygen are right next to each other. So we expect then that the bond between nitrogen and oxygen to be the least polar. So it will still be polar, but it'll be the least polar of the two. Okay. And so with that said, then if you take a look at carbon and silicon are in the same group. They're in the same group. However, carbon is one period above silicon, so therefore it's a little bit closer to fluorine than silicon is. So therefore, that bond it will form a slightly more electronegative bond with fluorine than nitrogen does with oxygen. And then finally, then, since silicon is a little bit further away, a group period down, the bond that it has with fluorine to be greater, the difference here will be greater than that between carbon and fluorine. Okay, and so that's what we see with that order there. Okay. All right, so with the last one, I think it's fairly straightforward and fairly obvious what you have there. Chlorine, chlorine, that's a non-polar bond. That should be your least polar. And with this group here, you would do the same thing. In all of these groupings here, chlorine is one of the atoms, and so therefore you look for the how far away the other atom is from chlorine. And so with that said, then, if you look at this, then you would expect then boron chlorine to be the most electronegative, the most have the greatest electronegativity difference. And then sulfur chlorine, and then finally chlorine chlorine would be nonpolar. Okay? And that's what we have right there. All right, so please make sure you write down the answer, the solution to the problem on your paper, and then make sure you have that ready to turn in at the end of this period. Okay. All right, let's continue on. Let's take a look at number 2 here. And in this case, then, what I'd like you to do, and make sure you read this question carefully, what it's asking you about then is the polarity. They want you to find which one of these bonds here is the least polar. Okay, it's the least polar, yet it still is a polar covalent bond. Okay, so read the question carefully, take about a couple minutes to answer the question, and then write it down on your paper, and then we'll come back in about a minute or so, and we will answer the question. Okay, so take about a minute or so, answer the question, and then hit play. Okay. Okay, let's take a look at this then. First of all, the question asks us about a polar covalent bond. We're asked about polar covalent bonds. Okay? And so they want us to find then the polar covalent bond that is least polar. Okay, so make sure you read that carefully. So let's go through this and let's identify the polar covalent bonds first. Okay? Let's take a look at this first compound right here, okay? Or this first bond here between magnesium and oxygen. This bond right here is between a metal and a nonmetal. So this is an ionic bond. This is an ionic compound. This is an ionic bond. So this is not a polar covalent bond. So you cannot include that in your answer. That cannot possibly be the answer. Okay, so that eliminates that one. We have 4 left over. Okay, now let's go ahead and let's go through and look at this one here. Now this is a covalent bond. Unlike here, this is a covalent bond, but this bond here is a non-polar. This is a non-polar covalent bond. This is a non-polar covalent bond. And this question is asking us about polar covalent bonds, so that cannot be your answer. So be careful about this. In the past, a lot of students have picked this answer because they said, well, there it is. There's your least polar bond because it's non-polar. And they would be right. They would be right. It's non-polar, so therefore it's least polar. But the question is asking us about a polar covalent bond. Okay? And so this is a non-polar covalent bond, so it cannot be your answer. Okay? And so therefore it comes down to bond between carbon and oxygen, silicon and oxygen, and nitrogen and oxygen here. And it's essentially the same type of question that you did in number 1. Just go ahead and look for the atom that is closest to oxygen, not furthest away, closest to oxygen, and that gives you then the least polar covalent bond. This is the least polar bond. Okay. Okay. And that's your final answer. Okay. So make sure you write that down. That would be your answer. Okay. All right, good. Let's try another one. Let's try another one. Take a look at number 3 in your problem set. We'll do a couple more, and I'm going to go for a little bit longer to finish up here, but I would like you on your paper, write the answer for the 3rd problem here in your problem set. Okay, so make sure you get that done. It's asking you which of the following bonds, so read the question carefully. Which of the following bonds would be most polar? And the question is, they're asking you about a polar bond here, which can be most polar without being ionic. Okay, so go ahead and answer this question. Take about a minute or so to answer this question, and then start the video up, and then we'll work it out. Okay, go ahead and get this done. Okay, so with that said, then we have here. Let's go ahead and take a look at this again. This can't be our answer because again, this is ionic. We already saw that in the previous example. This can't be our answer. This is a non-polar bond, so that can't be our answer. Okay, and so coming back down to this then. Which one of these bonds here have 2 atoms that are furthest apart? It would be silicon and oxygen here. Okay, we already saw in the previous example that nitrogen and oxygen is the least polar of the polar bonds. Silicon and oxygen are furthest apart. So therefore, this bond, then the bond between silicon and oxygen, should be the most polar. Okay? And that's what we have right there. So make sure you write that down and submit the work. Okay. All right. Very good. So with that said, then, when you have a polar bond, like we saw in the previous examples, when you have a polar bond, you have then an unequal distribution of the electrons in the bond. You have an unequal distribution of electrons in the bond, and when that does happen, then you essentially set up a charge separation in the bond itself. So if you take a look at the hydrogen-fluorine bond here, if you take a look at this hydrogen-fluorine bond, you'll notice that fluorine is much more electronegative than the hydrogen itself. And this pink cloud represents the electron density. So if you notice then on this particular molecule here, the electrons obviously favor the fluorine side because fluorine is much more electronegative. Therefore, the two electrons in this particular bond will spend more time on this side of the bond. They will spend more time with the fluorine. And if that's the case, we know then electrons are negatively charged. This side of the bond then will establish then a negative charge because if electrons spend more time on this side of the bond will be more negative. This side then will be more positive because that's a deficiency of those electrons. Okay? Now, do you understand? These electrons do not stay with the fluorine. This is still a covalent bond, so there's still a sharing. So what we're saying here then is that these electrons spend more time over here. They will occasionally head back over there, okay, but they spend more time over here. So because of that then, what we do is we set up a slight charge separation, in the bond here, so that you have one side of the bond being negative and one side of the bond being positive. If you have two opposite charges like that, then we're saying that you have a two pole. So therefore, you have set up what's called a dipole moment. This is a dipole moment because there is a charge that is positive on one side, charge that's negative on another side, and so they're separated. So this is what we refer to as a dipole moment, and any bond that has a dipole moment has a charge separation. So make sure you keep that in mind. And we represent this dipole moment with this arrow here, representing the direction in which the electrons will flow, and then therefore this arrow here represents that we have a dipole moment that is moving towards the fluorine side of that bond. Okay. All right. Let's go ahead then. Let's continue on. Okay, what you can see then, we can actually take a look at a bond with the dipole moment. Okay, and see then that it will also set up a molecule that is also going to be polar in nature. So if you let me go back here. If you take a look at this, if the bond is negatively charged, if the bond then has this separation here, if you take a look at the molecule, I'll just write it this way real quickly. You can imagine that the molecule is a sphere in that manner. Okay, if you take a look at that, then if the electrons are spending more time on this side of the bond, this side of the molecule, the fluorine side of the molecule, then will be negatively charged. So the fluorine side will be negatively charged, and the hydrogen side will be positively charged. The molecule itself has also a dipole moment. Now, that's what we have here. The charge distribution allows us to state that about this molecule. So not only do we have a polar bond here, but the molecule itself now is also polar in nature. It also has this dipole moment as well. And we see that with other polar molecules. Okay? Now, if you take a look at water, okay, let's take a look at water, and I'll finish up here, and then we'll pick up with this discussion tomorrow. Okay? If you take a look at water here, and if I put this on, you notice then that the bond here, oxygen's more electronegative. So the bond here is going to have a charge movement towards the oxygen. There's a dipole set up in this bond here, so that this side of the bond and that side of the molecule is going to be positive. This side is going to be negative. So you have this side of the bond being negative as well. Okay, same thing over here. This bond here between this hydrogen and that oxygen, this side is going to be positive. So this side is going to be negative on this side, on the oxygen side as well. So if you notice that if you look at the molecule as a whole, you can notice then that the hydrogen side of the molecule will be set up as the positively charged end, and that the negative side of the molecule is where the oxygen is located. So there is a dipole moment here. There is the moment, the overall charge of this molecule is going to have a positive towards the hydrogen side, negative towards the oxygen side. You can actually, and so that's what we have here. So I've set up here then that there is a dipole moment for the water. Okay, and you got to keep in mind here, and there's an important factor that we haven't considered yet, and that is the angle here, the angle between the two bonds here, and thus the geometry of the molecule as well. Okay, and so we'll pick up with this idea of geometry tomorrow, and how geometry plays into establishing a dipole moment and making the molecule itself polar, because you can have a molecule with a polar bond and yet still not have a net dipole moment for the molecule. And we'll talk about why that's the case tomorrow. Okay, but really, what you want to notice here is that with molecule with the dipole moment, if you set the molecule in a electrical field, you notice here then that the negative side of the water particle is going to point towards the positive electrode, and the positive side of the water molecule is going to face towards the negative electrode. Okay? And so that's what we have in this slide right here. Okay. All right. So what I'd like to do is I want to stop there. We will pick up with this discussion. I think that was about 20 minutes. Okay, we'll pick up with this discussion tomorrow with the discussion of geometry, and we'll make sure then that we get that taken care of. And then I'll take your questions after school today. Take a look at the work in your book. Take a look at the section in your book, 8.3. And then go ahead. I will post then the problem that you'll have to do. And this problem will be from your book this time. Get it done. Include it on your paper that you did the class problems on. And please make sure you have that submitted by 11:50 today. Okay, so good luck with you on that. This is going to be an interesting process, but we'll get through this. Okay. All right, so I will see you folks. Hopefully, I'll see a few of you folks after this afternoon on Zoom, and if not, I will talk to you again tomorrow. Okay. All right, folks. Have a good day.